What does brain imaging reveal about bipolar brain chemistry? Imagine peering inside the brain to see how its wiring and chemistry change during mood swings. Brain imaging studies give us a window into what happens in the brains of people with bipolar disorder. These studies show that there are distinct differences in both the structure and the chemicals in the brain that help regulate mood and behavior. Looking at the brain's structure, magnetic resonance imaging scans reveal that people with bipolar disorder often have thinner gray matter in the front and side parts of the brain. These areas are vital for controlling emotions, making decisions, and staying motivated. When these regions are thinner, it can make it harder to regulate feelings and impulses. Interestingly, those who have experienced psychosis tend to show more pronounced thinning, but medication can make a difference. For example, lithium, a common mood stabilizer, has been linked to less gray matter loss, suggesting it might protect brain cells over time. While the sensory and visual parts of the brain seem less affected structurally, during mood episodes, their activity can become disrupted, affecting how sensory information is processed. On the chemical side, positron emission tomography scans reveal that the levels of certain neurotransmitters, dopamine, serotonin, and norepinephrine, are altered in bipolar brains. These chemicals, called monoamines, are essential for mood regulation, stress response, pleasure, attention, and thinking. Changes in their levels can lead to the mood swings, irritability, and cognitive challenges seen in bipolar disorder. Although scientists have long suspected these chemicals play a role, imaging studies now provide direct evidence of their altered activity in the brain. Functional magnetic resonance imaging also shows that during sensory processing, like viewing visual stimuli, the brain activity in people with bipolar disorder can be less synchronized. This means the brain's response to stimuli may be weaker or less coordinated, especially during manic or depressive episodes. This disruption might explain some of the sensory perception issues experienced during mood swings. Beyond chemicals and structure, the brain's ability to adapt and change, called neuroplasticity, is also affected in bipolar disorder. Mood stabilizers like lithium not only help stabilize mood but may also promote brain health by supporting cellular survival and encouraging the growth of new connections. They influence factors like brain-derived neurotrophic factor, which helps keep brain cells healthy and connected. In summary, brain imaging shows us that bipolar disorder involves a complex mix of structural changes, chemical imbalances, and functional disruptions. These differences mainly affect regions involved in mood regulation, thinking, and sensory processing. Understanding these brain differences helps explain why people experience the symptoms they do and guides us toward more targeted treatments. It highlights the importance of medical management, including mood stabilizers, to support brain health and help manage symptoms. If you or someone you know is dealing with bipolar disorder, consulting healthcare professionals is essential for personalized care and effective treatment.